our World Steel webinar this morning. First of all, I want to wish you all happy World Steel Day for Safety and Health. Today is the 28th of April at the time of recording. This is the day of the year when the World Steel community comes together to look, really focuses on the safety and health risks and hazards faced by our industry. And it's really a great day to commence a series of webinars. Throughout this year, we'll be partnering with Draeger to deliver a series of webinars focused on the topic of gassing and asphyxiation, which is really one of the key causes of fatalities and serious injuries in our industry and others around the world. So I'm delighted to be here. I'm Andy Purvis. I'm Director, Sustainable Manufacturing with the World Steel Association. I would like to take a moment to introduce you to our speakers for today. Go to the next slide, please. Excellent. We have two speakers who you can see live from the Draeger studio in Germany. We have Ulrich Klenk, who's Training Development Manager at the Draeger Global Academy, Benedikt Muschk, who's a Senior Expert in Safety and Emergency Management at Draeger. Now, we would like this webinar to be interactive, so I would really like to invite you to ask us questions as we go through the process. You can use the Q&A function. It's better to use that than chat because they're captured if they come in via Q&A. So if you can type your questions as they occur to you into Q&A. At the end of the presentation, the guys will speak for around 40-45 minutes. We'll have a little time put aside for a bit of a discussion and to ask any of the questions that you raise. So if a question occurs to you at any time in the presentation, pop it in the Q&A and we'll take it from there. So on that note, I will hand over to our expert presenters who will be delivering our webinar today. Ulrich and Benedikt, good luck, and the floor is yours.
Thank you very much for this nice introduction. Thank you very much that we have the chance to be here to go a little bit more into details about the risks of gassing and asphyxiation. Benedikt will take over more the practical parts. For me, it's more the theoretical parts. Before we start content-wise, I first want to introduce the company of Draeger a little bit to you. Draeger is a family-run company located in the north of Germany, and our chairman at the moment is Stefan Draeger in the 5th generation of the Draeger family. Draeger is very close to its customers with the headquarters located in the north of Germany, but with many production sites, logistic centers, sales and service locations in many countries. And additionally, we also have sales channel partners in countries where Draeger not directly has a location. What do we want today? Today, we want to talk a little bit about risk assessment and hierarchy of controls, especially for the risk of gassing and asphyxiation. We'll start our topic today with a short introduction. If you have a look here at the statistics, you can directly see that gassing and asphyxiation is on position 3 of the World Steel Safety and Health Metrics Report 2021. The first point of this statistics was fall from height. Fall from heights was covered in the last World Steel webinar series last year. For this webinar series, we are going into gassing and asphyxiation. Where do we have the risk of gassing and asphyxiation? So think about confined spaces. Think about risk assessments. Risk assessments for confined space entries. Think about clearance measurements, leakage detections. If you want to do proper measurements, it's also about sensor selection. And of course, we have different kinds of work which is carried out, which needs a risk assessment also for the risks of gassing and asphyxiation, for example, maintenance work. Now, we will have a little bit a deeper look in the topic of risk assessment. You all know this diagram of our risk assessment process as a part of risk management. First questions we always need to do, we are establishing the context for which questions we are doing our risk assessment within our risk management. After that, it's about risk identification, risk analysis, and risk evaluation. After the risk assessment process, we are selecting countermeasures against the risk to reduce the risk. Let's call it risk treatment. It doesn't matter which method you have chosen to use for you and your company. One approach is the bow tie approach. Within the bow tie approach, we have hazards which can lead to an event. This event is based on a threat and leads at the end to some consequences. The task of risk assessment now is to identify which threat leads to which consequence and which control method is effective to reduce, for example, the threat on the left side of our bow tie, or to reduce the consequences on the right side of our bow tie. Why are we doing this? We are doing risk assessment and risk management to protect not only property like facilities, vehicles, machinery. We are doing this not only to protect environment like lakes, the sea, the forest, soil. We are doing this to protect people. People as our colleagues, people as our employees, and also the people in the near surrounding, the neighbors of plants and facilities. Now we go a little bit deeper in our risk assessment process. Risk identification is about finding, identifying, and describing the risks. So if you do not know what we want to talk about, if you do not know what we want to analyze afterwards, we have no chance to find measures to reduce the risk. After risk identification, we do the risk analysis. Risk analysis is a systematic procedure to determine the risk. Of course, there are different ways to do this. A little bit later on, we will show you some or one of those methods and giving you examples for that. After risk analysis, it comes to the risk evaluation. Risk evaluation is our procedure to determine the extent to which the previously defined safety objective is achieved in the case of a specific event, to show what residual risk remains and decision-making basis for determining measures to minimize or accept the residual risk. Those processes can be based on different standards. Here, as one example, the ISO standard 31000 of the year 2018. One of those methods is our risk matrix. Our risk matrix is helping us to express our risk. The simplest approach of our risk matrix can be seen here as our matrix 5.5 with our consequences and the severity of consequences from insignificant, so what matters, up to catastrophic, which is a very severe consequence. We also have the likelihood from rare, so this event takes place very seldom, up to almost certain. To give it some words, if you think about hitting your hand with a hammer and you do this once in your lifetime, it's rare. if you do this one a day, I think we have to consider other measures. Our risk can now be described statistically as a product of damage severity multiplied with our likelihood of occurrence. If we do this in the first step, we are not thinking about risk mitigation measures. We are calculating what will happen completely without any mitigation measure. So, Benedikt, may I please invite you to give us now an example from your practical experience?
Yeah, thanks, Ulrich. So during the processes at our customers, there can be several gases be produced. And today I would like to talk about carbon monoxide, which can be released in different processes too.
Have you an example for a process with carbon monoxide?
Yeah, of course, the whole steel production. So if we have a combustion, there often is carbon monoxide, which is released during the processes. And a good example is pits. So a lot of our customers have pits where there is the steel is brought to the pits, and there is coal monoxide. As we stick to the example, as you said, for the risk assessment, we have a serious problem if there is coal monoxide and we do not have any safety measurements.
What kind of problems be?
Those problems is the toxic problem of coal monoxide. If there is a certain amount of coal monoxide in the pit, and there will be an employee who is going into the pit to do, for example, to reduce a technical problem, there is a concentration which could be toxic to the employee. So this would be, if there's no safety measurement, this would be a catastrophic, as you said, problem and could cause the death of an employee. So of course, you always have certain safety measurements at your plants, but we just have, for example, this problem, okay, the death of an employee is catastrophic. And so the probability is given as a 5. For the likelihood of this is we have the example, we have taken a value of 3. So at the product of this is a 15.
So if you think on your processes, do you see also the likelihood of 3 that there can be carbon monoxide? And can you follow Benedikt in his example that this event, carbon monoxide, is present if there's a worker inside, is catastrophic? I think there's no questions. So, Benedikt, please proceed with this example. Now we are taking countermeasures.
Yeah, as we do or implement safety measures, for example, tactical measures, as you have no leakage, you have flanges which are very good. So you can reduce this from 3 maybe to 1. So you have a much more safe process.
So you are reducing the likelihood at this point.
Yeah, you reduce due to the technical measures, you reduce the likelihood. Yeah. So, and however, when there's still an incident and the percentage of and there is an employee into a pit, for example, we still need to do different things. For example, a measure would be to detect the gas which is in the pit. Often at our customers, they detect oxygen. So we have a percentage of 20.9 volume% of oxygen in the pit. So there is no question about they can work there safely. Often our customers just detect oxygen, and if there's a percentage of 20.7% of volume percentage in the pit, we have the problem that there should be or maybe is another gas. If we stick to the example coal monoxide, there could be about 2,000 parts per million of coal monoxide. This is a toxic atmosphere in the pit. So you detect oxygen, but you need to have a closer look what other gas could be in the pit.
So you say if the oxygen concentration is lowered and you do not know why, it's pretty sure that there could be another gas.
Yeah, exactly.
So thank you very much, Benedikt. I will come to you a little bit later with more examples. So now we have the risk of something we cannot directly see. We have an invisible risk. Within our risk management process, within our risk analysis, we are not able to express this invisible additional risk. I will give you now an approach how we can make the invisible visible also in our risk assessment. We are only adding one more factor in our equation, the noticeability N of a hazard. This noticeability can be immediately. For example, you see it directly. Then the total risk is not increased because the factor stays 1. To be in our example, it's possible, catastrophic, 3 multiplied with 5, we have the 15, but you can directly identify, you can directly see this risk, it stays with 15. But we are talking about carbon monoxide. Carbon monoxide is a highly toxic, invisible, tasteless gas you're not able to notice. It's invisible to human being. So our noticeability factor becomes 5. Our total equation, 3 multiplied with 5, so possible multiplied with catastrophic, multiplied with invisible, becomes 75 at the end of the day. Now we are able to express our visibility, our noticeability of hazards directly in our risk equation. Benedikt, I want to have one more example. Can you please give us here one more out of your experience?
Yeah, as you can see here, of course, you're all not beginners with safety measurements. You need to take care that these safety measurements are working together. As you can see here in this example, as you see, the first thing you need to know is you have to do, for example, gas measurement before the work, clearance measurement, as you said. As you can see, there is maybe a confined space where you have to work in. You have to see the fall from heights. You have to use certain protection equipment, and nevertheless, you need to have an emergency management. If there's an incident and if there's an alarm, you need to do something.
So, for example, a confined space like over here in our example. Now we have a measurement result in a high concentration leading to an alert, alarming the employees.
Right. So we have often a certain fatigue because of a lot of alarms which you have during your processes. But a gas alarm is a problem. So when you have a gas alarm, you need to do the right things. So you need to implement an emergency system so the employees can do the right things at the right time.
So what can be the right thing at the right time if the gas alert sounds?
Yeah, for example, they need to know where's the right escape route. They need to know what is to wear as a protection equipment to have a safe escape. And nevertheless, if there's a complex situation, you maybe need a rescue concept to bring, for example, some employees out of a confined space into a normal on the earth floor side to bring them outside.
A safe place where you then can see if every of your employees has made the way to the safe places. So thank you very much, Benedikt. We now will proceed a little bit more with our theoretical ideas. We now add a fourth factor to our equation, the time of exposure, E. What does this mean? I will come back to my very, very, very simple approach explaining you the risk, hitting my hand with a hammer. If I do this up to 1 day per week, or if I do this up to 5 days a week, the time of exposure is increasing. If we now use in our equation the time of exposure also as a factor 1 to 5, up to 1 day a week is 1, up to 5 days a week is 5, and we have now a risk equation, an equation for calculating the risk based on the likelihood, based on the consequences, based on the noticeability, and based on the time of exposure. We now can detailed express the risk in one equation. But why do we want to do that? why could it be a good idea to have now a much more complicated equation with 4 factors instead of having an equation with 2 factors? Because now we can take countermeasures to reduce risks. We have now not only 2 factors we can play with, we now have 4 factors we can play with. If we are now in reducing the risk, for example, by reducing the time of exposure, we are reducing the risk. If we are increasing the noticeability, we are decreasing the risk. This leads us to the hierarchy of controls. Also, the hierarchy of controls is based on different approaches. One approach is the STOP or the STOPP approach. Another approach is ERIC-PD. I will stay with ERIC-PD for today. ERIC-PD is an acronym used in our risk assessment and management to define the hierarchy of controls. This acronym stands for eliminate the hazard, reduce the hazard, isolate the hazard, control exposures to the hazard, personal protective equipment, and at the end, discipline and procedures. Discipline and procedures, what does this mean? You not only need to have personal protective equipment, your employees also must use this personal protective equipment as one example for discipline and procedures. With this hierarchy, organizations are helped to prioritize their risk control measures based on their effectiveness in reducing risks. We can also draw this here as a cone. The first step we always need to do is the elimination, physically removing hazards. Why? The elimination, physically removing the hazard, means we are protecting not only one person or a small area, we are protecting many persons and larger areas. Maybe we can replace or reduce the hazard. This is also called substitution, for example. We can isolate the hazard. We can isolate the people from the hazard, for example, by engineering controls. Our control measures can be administrative measures. For example, telling our employees, no, only one person needs access to the dangerous area. There's no need that there are 5 persons. At the end of the day, here comes the personal protective equipment and the discipline and the procedures. Personal protective equipment should only be the last thing considered. Personal protective equipment is not against the main risks out of a process. It's against the remaining risks after taking all of the other measures like elimination, replacing, reducing, isolation, and controls. Because it's only protecting one person, the person which is using the personal protective equipment. If you want to go a little bit more deeper into details about the hierarchy of controls and about ERIC-PD or other methods for the hierarchy of controls, please have a look at different ISO standards. For example, the ISO 45001 or 3 about health and safety. Now we come to our next example about ERIC-PD. Benedikt, would you please join me once more, giving us an example on ERIC-PD, on the elimination and reduction of hazards?
Yeah, of course. Due to the processes at our customers, it is often not possible to eliminate or to substitute a certain process point or a gas or a product. So if you want to implement measures, you often have to go to a technical part. You have to implement engineering controls, for example, such as the suction, for example, to get to lose the coal monoxide from a pit, for example.
So with a suction device, you're reducing, or in best places, eliminate the carbon monoxide in a smaller area or maybe larger area, depending on the setup of your suction devices.
That's right, yeah. Of course, you need to do a clearance measurement before you work in this places. Even a pit, if it's large and wide, it could be a confined space because of a dangerous gas, for example, coal monoxide. So you need to make a clearance measurement before you send your employees into this pit. Confined space entry is even a bigger part because you have to consider much more safety measurements for this. Nevertheless, you need an organizational topic, the alarm management and the emergency management, as I said before. Without an alarm management, and these alarms must be there for the employees and for other personnel, so that the emergency management can be part of a safe rescue and a safe escape route for the employees.
So can you go a little bit more into detail? For example, gassing and asphyxiation, where, for example, personal measurement devices comes into effect.
Yeah, when you have a personal measurement device with the employee in a pit and where you don't have a fixed gas detection system, there can be an alarm right with the person. So the person just knows when there's the alarm, how to escape and where to go. So this is very important.
With our new approach, or it's not a new approach, with our extended approach, adding more factors in our risk equation, we are now able to express those kind of hazards and the mitigation of those hazards in our risk equation directly. And what about the bow tie? Please let me bring the bow tie and the risk matrix together. Here you can see once more our bow tie with our hazard leading to an event, with a threat leading to an event, with a consequence out of the event. On both sides of the bow, you can take control measures to reduce, for example, the likelihood that a threat leads to an event, and you can reduce on the other side, by control measures, the severity of the consequences. Our risk matrix now, and once again, it doesn't matter if you're using a 5.5, 8.8, 3.3, or whatever kind of risk matrix you're used to, you're now able to express those effects on the side of the threats and on the side of the consequences within the bow tie. And if you have the extended risk matrix, our 4-factor risk matrix, you can also express the consequence of a threat after an event, also for invisible hazards, for example, gassing and asphyxiation. And of course, for the time of exposure to this hazard. So if we are now combining the bow tie with our risk matrix, this provides several benefits in our risk analysis. For example, we have an enhanced risk communication. With the bow tie, we have a graphical representation of the different phases and factors of our risks. We are now providing a clear and concise visual representation of potential hazards and their severity by numbers. This makes it easier to identify and manage risks at each stage of those processes. And that leads to an improved decision-making. The decision within health and safety in the workplace can be made better informed related to mitigation and risk management. We see more details if we make the invisible hazards visible within our risk equation. And as an engineer, you can trust me, I love numbers. Numbers allows me to prioritize our risk management efforts and so implementing more effective mitigation strategies. And this means we can allocate our resources much better. So at the end, we create a standard approach to risk management with an improved consistency in risk assessment and management across different projects and departments. Because if you're talking to different projects, project leaders, and to different departments, if you try to compare risk assessments of different departments, we can see that there's a huge inconsistency on how risks are seen. Ask your colleagues in the bureau what they are thinking about the use of ladders, putting folders out of the shelf, compared to those colleagues in your production site using ladders to do maintenance and repair work. Totally different sides of view on one and the same questions, nearly one and the same question. Now, by giving it numbers for likelihood and consequence, we have now at the end a risk given by a number, and we can compare the risk also across different departments. Easy, or? Overall, our combination of our bow tie and risk matrix is offering a powerful risk management tool which helps organization in identifying, assessing, and mitigate risks across different phases and factors of risk. To have this in only one sentence, combining the bow tie with our risk assessment approach with our risk matrix, we are now able to sort our bow tie by likelihood and the severity of consequences. So, if you want to stay into contact with Benedict and me, please feel free to contact us via LinkedIn. You can find us at LinkedIn via the QR code you can now see in the presentation, or by our names, Benedikt Mücksch and Ulrich Klenk. And while in the background some camera problems are fixed, I can tell you what is coming up next. Today, we have been talking about invisible hazards from risk assessment to risk mitigation and how to express invisible risks directly in our equation. And we have been talking about combining the bow tie approach with a classical risk matrix. On June 8th, the next webinar is about explosive gas atmospheres, preventive measures, and gas warning devices. On July 4th, my colleagues will talk about safe operations in confined spaces, and I'm very sorry for our colleagues in the United States that we have a webinar on Independence Day, but I hope you will join us by interest. August 31st, the webinar is about risks of gassing and asphyxiation at one special task during maintenance works. The last webinar of our webinar series on October 5th is about mobile gas detection devices as your life insurance. So far, from Benedikt and me, content-wise, I hope you have enjoyed our small webinar, and now you can see how it looks like having a green screen behind, because we have some technical issues. I'm sorry for that. But if there are any questions, so please feel free. I will now hand back to Andrew. Thank you very much.
Thank you, gentlemen. It's always nice to see behind the curtain of the flash of the studio how it looks in real life. That's great. Thank you. I think that was an excellent start to a series of webinars. You know, we're going to get quite technical, I think, going forward. But I think laying that foundation of risk management has been, I think, really useful. And you've added a couple of things there that I hadn't come across before. So we do have a few questions, but I'm going to indulge myself and ask the first one myself, if I could. You added, I think we're all used to 2x2 matrices to measure and assess risk. You're adding another two elements effectively to the consideration. So I guess we're moving away a little bit from how you think of risk as a 2x2 matrix to more of a spectrum of risk. We're just a number. That's what we're looking to manage in this case, right? So it feels a slightly different way of looking at risk to perhaps how we're used to it.
Yes, it's not a full new approach. It's only a very small step to get a chance to make the invisible visible. And at this point, I'm sorry, because the sound was a little bit not so good, so I did not get all of the question.
Oh, I'm sorry. Now, is it better now?
Yes.
Good. I was commenting on the fact that we're not, when we use this, I guess, additional elements, we're moving away from the 2x2 matrix that we're used to using to something that's probably more a spectrum of risk. So we're really managing the number more than the 2x2 that we're kind of used for using. So I thought that was an interesting addition. We did have a few questions. I'm going to take the first one myself. Someone asked about what the controls look like in a bow tie. I just wanted to encourage folks. World Steel's done a lot of work with bow ties in process safety. So if anyone who's a World Steel member would like to see some really good examples of bow ties applied to issues like DRI production, like blast furnace and water, there's a lot on our member extranet which are available to members to use those. So please take a look at those if you want to know a little bit more about that. Now, moving to the questions that have come in from our participants as we go through. There was one, maybe just ask if you could explain a little bit more about the final step of the hierarchy of controls. Could you just summarize the hierarchy, and particularly the ones towards the bottom, I think, when we move away from towards PPE and procedures?
Yes, in the hierarchy of controls, we first try to protect the collective side. So as many persons as possible, as large areas as possible. For example, by eliminating the risk, eliminating the circumstance that we have a gas here. In many processes, we are not able to eliminate anything. For example, pit mining. For example, the usage of coal always leads to the effect that we have gases nearby workplaces. So the next step is, what can we do next? Can we cover this to avoid gases to be set free? Yes, we can, but it's not practical. We cannot work anymore with that. Okay, what's the next question? What can we do then? And at the end of the day, we're coming to the conclusion, okay, here's a residual risk remaining, and we can only handle this residual risk, which we have reduced as far as possible, by using personal protective equipment. This can be, for example, breathing protection directly, or can be a warning device giving us a warning if the gas concentration gets too high, so that I know I need to use my breathing equipment to get out. To use my breathing equipment to reach a safe point. So what kind of different personal protective equipment can here be considered? So nearly everything. Depends on which risk remains, which is the residual risk I need to reduce at the end for the one person, for each one person.
If you use personal if you use personal protective equipment, so there's a possibility there's even a dangerous situation because of a gas. So the approach is to get the other steps first, because you don't want to have the gas in this situation. So personal protective equipment is the last step. You just don't want to use it. If there's a dangerous situation, of course, it is good to have personal protection equipment, but you want to have this risk as small as possible.
And now in ERIC PD, after personal protective equipment, we also have discipline and procedures. So if I'm offering my workers, for example, breathing protection, this is the first step. The second step is I must be sure that this breathing or protective equipment is be used by our workers. This is meant by discipline. And if I'm using protective equipment like breathing apparatuses, I also need to train on a regular basis our workers in the usage of our breathing protective equipment. This means we need procedures also for training.
Yeah, and that's a really, I guess, a good reason for to try and use the top half of the pyramid, right? Because people will make mistakes, and the further we can move away from people's behavior as what needs to keep them safe, the more likely we'll be in a good situation. The guy who was asked if we can show the slide. I don't think we can show the slide at the moment, but I can tell you that we've recorded the whole presentation, and we will make the presentation. Oh, we can. There we go. So there's the slide. Okay, well done. Thank you for that. We will make the whole webinar available through Steel University, so you can go back and review it. There were another couple of questions, gents. In terms of the effectiveness of your risk management strategy, what would be the best way to, I guess, measure and understand how effective you have been when it comes to reducing risk in your whole approach?
This depends. So if you want to measure the effectiveness, you need to talk about what you want to, what is your approach where you want to be. If you don't want if the health of an employee is the most important topic for you, so you don't want to have time which the employee cannot work. You don't want to have a certain injury. A KPI is very a key performance indicator is very difficult to isolate. So this is a type of, let's say, safety culture thing.
Mm.
So if your safety culture also includes, for example, near miss reports, the first thing you can see that the number of incoming near miss reports is reduced for the topics you are actually handling with the control measures.
Sure. That's great. I mean, you can probably take the slide off now so we can see you again, if that's possible, studio guys, so we can see our presenters. Oh yes, of course. There we go. Back to the green. That's great. I think I have another question here. I mean, you guys work in many industries, and you have perspective and views across a lot of sectors. What would you say, particularly the steel industry, what the major challenges we face in implementing these kind of risk reduction strategies, perhaps compared to some others?
Yeah, it's the same topic. It's safety culture. So what is the awareness of the employees about risks and hazards? What does the employees, what they want, what they are capable of to do with risk, and how they proceed with these risks. So it's also a safety culture thing.
Yes. Okay. One more's come in. Perhaps it's exploring the hierarchy of controls again. Just an example. I know we're here talking about asphyxiation, but one of our participants is asking, particularly about work at height. Maybe that's a good example. You know, if you've got something, a job that has to be done at height, if you can't, eliminate the fact that the height is there, what kind of controls could you use in that example to reduce and control the exposure to the hazard?
I want to simplify this example a little bit. Is this working in heights is done with a ladder, for example? You can replace the ladder, for example, with a lifter.
Yes.
So you're not working on a ladder where you can fall down, which can be pushed in each direction. You're working from a ladder. You have a technical measure, and of course, the borders between each step are not sharp. This is flowing between every kind of those steps. So if you are using a lift instead of a ladder, you reduce the risk of falling from height. But there's a small risk remaining. We all know if you are using lifters, we also must use ropes to be fixed in the ladder itself, in the lifter itself, because there's a small risk remaining by doing the work that we can fall off the lifter. One very worst example I have for this, we had one time the case, the lifter was blocked on an edge while going upwards in something like 40 meters of height. The driver of the lifter doesn't recognize not switching off. So we have a force like a spring on this lifter. And what happened if the edge breaks?
Yes.
The lifter makes with a high amplitude a movement, and the workers, two of them inside the lifter, fell down. So we have a small remaining residual risk. We need personal protective equipment also to reduce that kind of risk. In that case, using personal protective equipment against falling from heights inside the lifter.
I think that's a really good point, isn't it? Because introducing controls can introduce new risks. So it's really important to look at this holistically. I mean, I would just add that, it is possible sometimes to think creatively around these things. For example, if you're doing work at height for inspection, there's companies increasingly using drones to eliminate the need to go high to carry out inspections. It's possible to relocate valves, perhaps, that are at height that need inspecting to ground level. So there are things that can be done. And if your interest is particularly in working at height, I'd encourage you to go to steeluniversity.org. Last year, we ran a whole suite of webinars around different elements of working at height. Those are all still available. So please take a look at that as well. I'm going to ask one more question, if you could indulge me, gents, which has come in, I think from Japan, looking at the name. So good evening. It's regarding visible invisibility. And the question is, the visible invisible element is part of criticality. Could you explain what the main advantage is to separate visibility, particularly from the criticality of the risk?
The criticality or the severity of the consequences may express the harm to the person based on how many days the worker cannot come back to work, maybe based on death of a worker, maybe based on an injury to the worker. If we now add additionally the visibility, invisibility, we have now a small additional steering approach to identify what our countermeasures do to our total risk approach. So we are not expressing it in, we have not longer a death worker because the warning device was sounding early enough so that he was able to use the breathing protection for escape, to using an escape device. We are now saying he was able to recognize the hazard, to recognize that there is the risk of a gassing, that there's a gas release. And now we can play a little bit with how sensitive must the gas sensor be so that the person can recognize the gas release as soon as possible to have enough time to use the escape device. So now we have a chance to go much more into detail.
That makes a lot of sense because these gases, gases are particularly challenging in terms of risk assessment because, as you say in the title of your webinar, they're invisible largely, and that's a really difficult thing to deal with. So I think it would be a good time to close out. I would like to thank our participants. I would like to thank our speakers today. Again, I'll answer the question. Yes, we have been recording the webinar. We will make it available through our Steel University platform at steeluniversity.org. We'll need a little bit of time to edit and get everything ready, but that will be available. So thank you for that. Please stay in touch with us at World Steel and at Draeger through our socials and various other things. We look forward to our next webinar, which will be held in June, where we'll start to talk about some of the more technical issues related to gassing and asphyxiation. So thank you again on this Steel Safety Day, and I look forward to talking to you again in June. Thank you, bye. Thank you all, and goodbye.